Hi everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to subject CHM421, which is analytical chemistry. This video will cover the topic 1. It is a unit for quantities and unit for concentration in the subtopic of mole and millimole. For every topic, I would like to start with remind you about the description of the subject and also the course learning outcome. In order to make sure all the students understand what this subject all about. As I explained in the previous video, these subjects will involve theories and techniques in analytical chemistry. You, as a student, will define the concept, explain the principle in application, solve qualitative and quantitative problems, performing experimentals in laboratory. You also will be assessed through the paper examination, test and quizzes, laboratory skills, and laboratory report. At the end of the course, you should be able to describe the function of laboratory apparatus, standard laboratory techniques, as well as the principle involved in sampling and preparing the laboratory samples. You should be able to explain the principle and applications of conventional analytical qualitative technique, volumetric, gravimetric, and basic chromatography analysis to solve the reliability of experimental data. The student should be able to demonstrate the theories you learn in this subject by performing the experiment on volumetric titration, gravimetric analysis, and chromatography. Last but not least, all the students are expected able to write the report on experimental finding in scientific manner. For this topic 1, uh, unit for quantities and concentration, there are a few subtopics that you need to be covered. First, mole and millimole. Next, molarity, normality, and stoichiometry. And then significant figure in uncertainty, percentage concentration, ppm and ppb for solid and liquid samples. And lastly, density and specific gravity of solution. Okay, for this video, we will discuss a lot on the subtopic of mole and millimole. First of all, you have to define what is mole. Okay, mole is you need to define the quantity amount of substance. Scientifically, it can be defined as the number of elementary entities of a system that contain the same number of atoms that exist in exactly 12 grams of carbon 12. So the mass and gram of 1 mole of substance, we call it molar mass. So two things that you have to be focused on this slide is the definition of mole and also molar mass. As I mentioned just now, molar mass is a mass of gram in 1 mole of substance. For example, if we have 1 mole of water, the mass in grams is 18 grams. How do you can obtain this 18 grams? You have to refer to the chemical formula of water, and you have to do the calculation using the atomic mass from the periodic table. For water, for example, it has two hydrogen atoms. This why we have to multiply 2 minus 2 multiplied 1. 1 is the atomic mass of hydrogen plus 1 oxygen atom multiplied with 16. 16 is atomic mass of oxygen that can be obtained from the periodic table. Therefore, the molar mass of H2O is 18 gram per mole. So this 18 gram per mole also can be written is 18 gram per mole. Another example is 1 mole of CO2 uh, from the chemical formulas and also the atomic mass of periodic table. From the periodic table, you can calculate the molar mass of 1 mole of CO2. As you can see from the formula, it is 1 carbon atom multiplied with 12 atomic mass of carbon plus 2 oxygen atoms multiplied with 16 atomic mass of oxygen that can be obtained from periodic table. It gives you 44 grams. So the molar mass of CO2 is 44 grams per mole. This 54 gram per mole also can be written is 44 gram per mole. Okay. All right. So I hope you can understand what is mole, and then what is molar mass, and how to do calculation related to molar mass. You should have the chemical formula and also the atomic mass from the periodic table. Okay, slightly detail on the mole concept. In the daily life, we always heard about the word of dozen. 1 dozen, 2 dozen, 3 dozen, 4 dozen, and etc. We can understand when someone said, can you give me 1 dozen of egg? Automatically, you can understand 1 dozen of egg is 12 quantity of eggs. If someone requests you 2 dozen of egg, you can tell it is 24 of egg. However, if someone, for example, is asking you, can you give me 1 mole of egg or 1 mole of apple? Do you can understand how many is 1 mole of egg? How many 1 mole of apple? Yeah, in this slide, you have to understand the mole of concept. Before we talk about this one, uh, the mole, the quantity of substance can be abbreviated is mole with the symbol of M. So The important facts in this slide, we can say 1 mole of anything, 1 mole of any substance, 1 mole of egg, 1 mole of apple, or 1 mole of strawberries is equivalent into Avogadro number. So we can write it here. 1 mole in terms of quantities, the number of quantities is equivalent to Avogadro number. So 1 mole is equivalent to Avogadro number. Avogadro number is 6.022 times the power of 23. Meaning that if someone asking you, can you give me 1 mole of egg? You will give him uh, you will give him 6.22 power of 1023 eggs. Okay, because 1 mole is equivalent to Avogadro number. All right. This sentence is about molar mass. The molar mass, sometimes we can call it molecular mass, is the 1 mole of any pure substance has a mass in gram, is equivalent to molar mass. How about 1 mole of ideal gas? 1 mole of ideal gas has volume of 22.4 liter at STP. What is STP? Standard temperature and also pressure. The temperature, it should be at 0 degrees C or 273 Kelvin. The pressure should be 1 atmospheric pressure ATM or 101.3 kilopascal. In this slide, what I want you to understand is the mole concept. 1 mole is equivalent into Avogadro number. Okay, some easy exercise related to the mole concept. Is we know 1 mole of anything is contained of 6.022 times 10 to the power 23 units of the substance. So if the question is asking you how many bananas in a mole of banana, so it's easy to answer. 1 mole is equivalent to Avogadro number. This is why 1 mole of banana is contained about 6.22 times 10 to the power 23 of banana. If the question is asking you about how many books is a half mole books. Half mole is uh, half mole, meaning that half Avogadro number. This is why the half mole of books is contain 3.011 times 10 to the power 23 books. Another question, what is the mass of 1 mole of magnesium atom? So this one is related to molar mass. Molar mass of magnesium. From the periodic table, we can obtain the magnesium atomic number is 24 gram mole minus 1. So this is why 1 mole of magnesium atom contain 24 gram. So uh, this molar mass can be understood in this way. Because the molar mass of magnesium is 24 gram per mole, so you can say 1 mole Mg is equivalent to 24 gram. Like uh, 1 mole, like molar mass CO2 that we calculate just now is 44 gram per mole. So we can understand this one, 1 mole CO2 contain of 44 gram. Okay. All right. Last question. What is the mass of 2 moles? It's asking you about 2 moles of ammonia molecule. So you can calculate slowly. Like first you have to calculate uh, 1 mole ammonia is containing of 1 times 14 plus 3 times 1 equivalent to 17 gram. So 2 moles ammonia equivalent to 17 times 2 is 34 gram. So this one, okay. So 2 moles of ammonia is 34 gram. So this is the answers. Seems with the answer given. All right. Okay. This slide is give you the formula to calculate the number of mole or to calculate the moles in unit millimoles. Okay. Moles normally is a mass over molar mass. You make sure the units are correct, gram per gram per mole. For the millimole, milligram per millimole. Sometimes it is more convenient to make calculation with millimole rather than mole. So this is some relationship between the millimole and mole. So 1 millimole is equivalent to 1 times 10 to the power 3 mole. Why? Because of milli is 10 to the power minus 3. It also can be written as 0.001 mole. So because of the power of 3 minus 3, you have to reverse the decimal point. 1, because of minus 3, you have to reverse backward. 1, 2, 3. So you can obtain 0.001 mole, similar to this. Okay. So another straightforward relationship is 1 mole equivalent to 1000 millimole. How come you can get this relationship? 1 mole equivalent to 1000 millimole. You can do simple mathematics. You can see here, is uh, 1 millimole is equivalent to 1 to the power of minus 3 mole. If you want to know what is the 1 mole in millimole, you put it x. So therefore x is 1 times 1 over 1 times the power minus 3. So you can obtain 1 times 1 is 1 divided 1 times power minus 3. So you get 1000. Sorry, you can get 1000 millimole. Okay. So seems to, yeah, 1 mole equivalent to 1000 millimole. Okay, we do some simple exercise related to the mole and millimole. In this question, it asking you about how many moles and millimoles of benzoic acid. The molar mass of benzoic acid given, the mole and millimole for 2 grams of pure acid. As we know, in order to calculate the mole, it should be gram per gram minus 1. Or in order to calculate the millimoles is milligram per, sorry, it should be uh, milligram milligram per millimole. Okay, so you can calculate one by one. I think I give you one for, I give you this is the answers, but you can try. You can try on your way to calculate this. Okay, so as we know, mole is mass over molar mass. Therefore, the moles is 2 gram over 1 to 2.1 gram per mole. So you can calculate this using your calculator. 2, I clear first. 2 divided 1 to 2.1. So you can obtain 0.010166364 6 4 mole. Okay, so it asking you about in millimole. So you can convert this 0.0164 mole to millimole. So meaning that milli is 1 the power of minus 3. So you can obtain 0.0164 divided 1 to power minus 3 equivalent to 16.4 millimole. Okay. You can also use the relationship proof of 1 mole equivalent to 1000 millimole. But I don't want to use this relationship because I can understand if you want unit milli, milli is equivalent to 1 times power minus 3. So you can obtain the same answer. Okay. Another exercise. Determine the mass in gram of sodium and 25 gram of sodium sulfate. It's asking you within this 25 gram of sodium sulfate, how many gram of sodium plus? So this is the question. So first, you have to calculate the moles of sodium sulfate. So as we know, mole is a mass over molar mass. So the mass of sodium sulfate is 25 gram. The molar mass of sodium sulfate is given in the equation 1 or 2. So when you calculate using calculator, you can obtain 25 over 142 equivalent 0.176 0.176 okay. So this one 606, or you can write it in 4 decimal point. You can write it in 4 decimal point 0.1761 mole sodium sulfate. 4 decimal point are also enough, but not less than that. So next, you have to calculate the mole number of sodium and sodium sulfate. So because of two atoms of sodiums in this sodium sulfate, therefore the number of mole of sodium sulfate should be multiplied by 2. So you can obtain 0.3521 mole. Why you have to multiply by 2? So if you still remember about the basic of chemistry during the foundation or during the SPM, you can write the dissociation equation. Sodium uh, sulfate can be dissociated into sodium plus SO4 2 minus. Uh, because of sodium, it has two sodium atom. So in order to make a balanced equation, is the 2 in A plus. So if we have 0.1761 mole of sodium sulfate, this why the mole of sodium plus should be 2 times 0.1761 mole. Okay, so it seems goes to here. So when you obtain the moles number of sodium in sodium sulfate, it is automatically you can calculate the gram or the mass of sodium sulfate. Sorry, the gram of sodium, because from the chemical formula, mole is the mass over molar mass. If you want to calculate the mass, the mole should be multiplied by molar mass. This is why you can obtain by using a calculator uh, 0.3521 times 23 is the atomic mass of sodium. So you can obtain 8.0983. So this the final answer. You can write this final answer in uh, 1 decimal point also can, okay, or 2 decimal point, 8.1 gram in 1 decimal point. This is the final answer. Or you can maintain is 4 decimal point. It's up to you. Okay, 4 decimal point or 3 decimal point. 4 decimal point also can. 3 decimal point also can. All right. Okay. This table is nothing much. It's just show you the several sample quantity in unit. Okay. For moles, the number of moles, the amount of substance, the symbol N in the unit mole. The mass normally in a gram, unit symbol of M. Molar mass, capital M, so it's a gram per mole. The number of anything, a number of atoms or number of molecules or number of ion, the symbol is N. So Avogadro number, the symbol N minus 1. So you can change this one into 6 to the power of 2 times 10 power 23. Also, you can, of course, you can use 6.02, but we standardize because on the earlier slide we using Avogadro number is 6.022 times the power 23. Okay. Uh, this is another presentation about mole. Is we understand already in order to calculate the mole, it should be mass over molar mass, small m over capital mm, okay, or gram per mole. And uh, if one convert mole into millimole, so whatever mole you should multiply by 10 to the power minus 3. This one is not is incorrect. It should be 10 to the power minus 3. And as we did together previously, we know 1 mole is equivalent to 1000 millimole. So from the formula of mole, we also can calculate the mass. Okay, mass is the mole times molar mass. It's can given in this triangle. If you want to calculate the mole, it should be mass over molar mass. If you want to calculate the mass, it should be mole multiplied molar mass. But it's no need to memorize this triangle. No need to memorize this triangle. As long as you know the formula to calculate the mole, you can play around to calculate using the same formula to calculate the mass for particular substance. Okay, this is another exercise related to the calculation of moles. Calculate the number of moles in 120 gram of copper sulfate. This why it's a very straightforward. Mass is already given 120 gram. However, you have to calculate the molar mass of copper sulfate. You can refer the periodic table. So from the periodic table, copper sulfate 60, copper 63.5, sulfur 32, and oxygen 4 times 16. You can obtain 159.5 gram per mole. So the formula to calculate the mole is mass over molar mass. This is why 120 gram over 159.5 gram per mole, and then you can obtain uh, 0. Uh, 0.7523. Okay, 120 over 159.5. So you can obtain 0.7523 or 24. 24 it's not 23, it's 24. Okay, it's 24. Okay, this one is 24. So in a mole, so you can convert this mole into millimole. 0.7524 moles uh, times milli, then the power of minus 3. You can obtain, you can get the result of 0.724 divided 1 over, sorry, 1 to the power of minus 3. So you can obtain uh, 7.2.4 millimole. Okay, all right. Okay, okay. Another exercise. Calculate the number of millimole in 500 milligram of this compound. So first, you still remember a thing, millimole. Okay, millimole should be mass and milligram over molar mass and milligram per millimole. So first, you have to calculate the molar mass of this substance. You can refer to the periodic table. So magnesium, 2 magnesium times 24, phosphorus 31 times 2, oxygen 7, oxygen atom times 16, and then you can obtain this one, 221 gram mole, or even you can write it 221 milligram per millimole. So if you want to calculate the millimole, as I mentioned just now, you have to using this formula, the milligram over the milligram per millimole. So 500 milligram divided 2 to 1 milligram per millimole, you can obtain 2.26 millimole. Okay, all right. Okay, you can try this exercise. How many grams of sodium ions are contained in 4.62 gram of sodium PO4? This is quite similar with the previous example. The answers given here, you can try. Also, this is another question that you should try. What is the what is the weight of 1.5 moles of calcium chloride? It asking you about what is the mass. This weight also can be what is the mass of 1.5 mole of calcium chloride. So in order to calculate the mass, you know is a mole times molar mass. So the number of moles is already given. So you have to calculate the molar mass of sodium chloride. And then you can obtain the number of mass for 1 mole of calcium chloride. So how many calcium chloride particle is asking you about particle in this compound. So as we know the relationship 1 mole is equivalent to Avogadro number 6.22 to the power of 23 particles. So you are given the number of moles. So I think by using this relationship, you can calculate 1.5 moles equivalent to how many particles. All right, you should try this exercise because the questions related to number of moles or the number of millimoles can be asked in various way. Okay, you have to try several types of question. All right, now we come up to the empirical formula and also molecular formula. What is the empirical formula? Empirical formula is the formula of compound that gives the samples the simplest whole number ratio between the number of atoms of different element making up in the molecule or compound. Molecular formula is indicate the number of atoms in any molecule or compound. So this is a common example of calculation related to the empirical formula and also chemical formula. All right. In this question, vitamin C or ascorbic acid, it contains of carbon, hydrogen, and also oxygen with different percentage, mass percentage. The experimentally determined molecular mass is 176 gram per mole. So the question is asking you about the what is the empirical formula, what is the molecular formula of ascorbic acid. So it's very easy because it's already given the percentage, mass percentage, and also given the experimental molecular mass of the ascorbic acid. So as we know, this ascorbic acid is contained of carbon, hydrogen, and oxygen. The mass percentage, the mass percentage, the total is 100%. So the mass percentage for carbon is 40.92, for hydrogen is 4.58, and for oxygen is 54.50. So first, you have to calculate the mole of each element in the ascorbic acid. meaning that the mass you have to divide it by atomic mass of that element. For example, for carbon, we have 40.92 divided by 12 gram because 12 carbon is 12. So you can obtain the mole number of carbon 3.41. Same goes to the hydrogen, 4.58 divided by 1 gram per mole. Oxygen 54.50 divided by 16, you can obtain 3.406. After you calculate the mole, you have to calculate the mole ratio. So the ratio, the mole that you obtain just now have to be divided by the smallest number among the mole. So as you can see, the smallest number between carbon, hydrogen, and oxygen, the smallest number is this one, 3.406. So each mole have to divide it by 3.406 divided by 3.406 and divided by 3.406. And then use your calculator, you can calculate the mole ratio. This one, 341, if you calculate, if you use your calculator, 3.41 divided 3.406, you can obtain 1.001. So it can be round up to make it 1. So 4.81 divided 3.406, so 8.34. Okay, you cannot round up because it's too far. In last but not least, 3.406 divided 3.406 is equivalent to 1. So now the mole ratio is 1, 1.34, and also 1. But you cannot stop here because the empirical formula is the simplest whole number. It's meaning that it's not in decimal point. It should be whole number ratio. So now we have decimal point. So we have to do something on this one. We have to make it decimal into whole number. So we have to, this one it should be okay because it's already whole number. So this one we have to do something. So meaning that we have to try multiply by 1, by 2, by 3, or by 4, and so on and so forth until you get the whole number. So we should try 1 by 1. If we multiply by 1, you can get the same answer. So we multiply by 2. For example, if we multiply 1.34 multiplied by 2, you can obtain 2.68. So we cannot round up. It's a very far. 2.7 is not whole numbers. So we have to try 3 maybe. So 1.34 multiplied by 3, you can obtain 402. So, sorry. So you obtain 402. So you can round up into 4. So 4 is whole number. Maybe you can try multiplied by 4. 1.34 multiplied by 4, 5.36. So we cannot round up because it's a very far. It gives you 5.4. So definitely you can use times 3. So when you times 3, you can obtain the whole number of 4 for hydrogen. So this one you also have to times 3 and also times, and also times 3. So this why you obtain that this is times 3, it's not times 4. This why you obtain 1 times 3 is 3, 1.34 times 3 is 4, 1 times 3 is 3. So so now you already have the whole number. So the empirical formula of this ascorbic acid is initially you're not really sure. You said CX, HY, or Z. And then after you do calculation is in this table, you obtain the whole number, carbon 3, C3, hydrogen H4, and oxygen O3. And then you can calculate the molecular weight, uh, 88 gram per mole. So this one, how you can get 83? Uh, 3 times 12 plus 4 times 3 plus 3 times 3 times 16. And then you can add 83 gram, 83 gram per mole. All right. So it's in a question you are given the molecular mass of ascorbic acid determined by using experimental is 176 gram per mole. So this 176. So in order to get 176 gram per mole, meaning that this molecular mass of empirical formula, you have to multiply by 2. 88 multiplied by 2, you can obtain 176 gram per mole. This why this empirical formula you also multiply by 2. So this why carbon becomes 6, hydrogen becomes 8, and also oxygen becomes 6. So this is the chemical formula. This is the empirical formula. Okay, I think this all for this video. Thank you very much. See you again next time. Assalamualaikum warahmatullahi wabarakatuh and bye-bye.